All right, we're going to be looking at lesson 6.3 today, which is elimination, okay? And what we're going to do is we're still going to find those exact solutions. We're just going to eliminate a variable, okay? So when we look at, like this first example here, think back to like kindergarten, when life was easy, or first grade, elementary school, whatever. When life was easy, and you got problems like 2 plus 6, and then you would write 8 down and everybody was super happy. Okay? It's the same kind of thing. We're going to be working up and down. Okay? So when I come over here and look at this, I'm going to draw a line, and I'm looking for something that can eliminate. 2 and 6, maybe not so much. But if I look at the positive 5 and the negative 5, those would cancel each other out. So we're going to eliminate the y's. So when I eliminate, these are going to cancel. It's going to be an addition problem. Okay? And then you're just adding up and down. 2 plus 6 is 8x equals, and then on this side, you've got 17 minus 9, which is 8. So then you'll finish solving the equation. So divide both sides by 8, and x equals 1. All right? So again, we're just canceling out the y's. A positive 5 and a negative 5 will cancel each other out. Now, just like we did with substitution, now you're going to take the x equals 1 and you're going to plug it into either one. It does not matter which equation you plug it into. I'm just going to plug it into the top. So you will end up with, when you do that, you're going to get 2 times 1 plus 5y equals 17. So now just solve your equation. So 2 plus 5y equals 17. Subtract the 2 off. So 5y equals 15, and then divide, and you're going to get y equals 3. So your coordinate point will be 1, 3. Okay, so that's what elimination will look like. All right, so let's go to the next example here. So now when I'm looking at this next example here, okay, if I'm looking here at the -3, -4, there's a no-go there, okay? So my focus has got to be the 3's, okay? But they don't actually cancel each other out. If I'm thinking about like 3 plus 3 here, 3 plus 3 would be 6. So to get them to cancel out, we are going to multiply this guy by a -1. So when we do that, we're going to change all of our signs, all right? And so because I've multiplied the second equation by -1, now these will cancel out. So I'm going to draw my line here. These will cancel. And again, you're just working up and down. -3 plus 4 is 1y or y equals 9 minus 5 is 4. Okay? So you can, they call this, in the textbook, they'll call this a subtraction problem, but I just said let's multiply it by -1 because you're going to need to remember to change all your signs. Okay? All right, so then you're going to go ahead and plug this in. And again, I'm just going to plug into the top. So 3x minus 3 times 4 equals 9. So 3x minus 12 equals 9. Add the 12 over and get 3x equals 21. And then we're going to divide and get x equals 7. So your coordinate point at which they're going to cross will be 7, 4. All right, so let's look at example C here. Okay, so when we look at this one here, we've got a -2 and a 7. Those aren't going to cancel. And we've got a 15 and a -5. Unfortunately, those are not going to cancel either. So when I'm looking at these, you just need to pick one and get them to cancel out. So we're going to multiply, just like we did back in example B, we're going to multiply one or both equations, okay? So if you really wanted to, you could go ahead and cancel out the x's. And to do that, I would multiply this guy by 7, and that would give me a -14x. And then I can multiply this guy by 2, and that would give me a 14x. And then you can see there how those would cancel out. Now, to do that, though, you would have to multiply everything by 7 and everything by 2. To me, though, I think it would be easier in this case to go ahead and get rid of those y's. Because when I'm getting rid of the y's, I can just multiply by 3, and that's going to give me this -15y. So now these guys are going to cancel out. So I'm going to go ahead and do it with the red one here. I'm going to multiply by 3. Now remember, you got to multiply everything by 3. Okay? So the top equation, I'm not doing anything to it. So -2x plus 15y equals negative 32. And on the bottom equation here, I'm going to take 3 times the 7, all right? So just make sure you understand you're multiplied 3 times the 7, 3 times the 5, and 3 times the 17, okay? So 3 times the 7 will be 21x minus 15y, and then 17 times 3 is 51, so equals 51. Okay, now once I do this, I'm just going to be focusing in on these two guys. I'm not going to worry about these two up here anymore. All right, so now that we've done that, now the y's will cancel out because it's a positive negative, so they cancel right away. Negative 2 plus 21 is 19x equals, and then 51 minus 32 will give you 19, and you divide and get 1. Now, when you plug in, I always tell kiddos to go ahead and just plug back into one of the original problems. Could you plug into the one where you multiplied it by 3? The answer is yes, you could do that, but I don't know why you'd want to, since those numbers are so much bigger than the 7, negative 5, and 17. So for this particular problem, I'm going to go ahead and I'm going to take this and I'm going to plug it in for the x right there. So I'm going to get 7 times 1 minus 5y equals 17. And now I'm going to subtract the 7 off. Oh, I don't need to really show that, do I? So I'm going to subtract the 7 off and get 10, and then divide and get negative 2. So my coordinate point will be 1, negative 2. All right, so let's go to D. So now we have kind of the same thing here, where we're not going to get our x's to match or our y's to match. And in this case, unlike C where I can multiply one and get them both to match, I'm going to have to multiply both equations here on this one. So it's just, it doesn't matter. You can do the x's, you can do the y's. It truly does not matter. So since we canceled the y's on the last one, I'm going to go ahead and we'll cancel the x's on this. So now, I need them to get the same, so 3 and 4 has 12 in common. So I'm going to multiply this guy by 4. And I'm going to go ahead and multiply this guy by a negative 3 instead of a positive 3. That way my signs will be opposite and I can cancel. So now, keep in mind, again though, you're going to multiply all 3 parts by 4. So you're going to get 12x plus 8y equals 4. And now multiply your bottom equation by negative 3. Okay, and we're going to get negative 12x, a negative 9y, and a positive 6. So the 12x's will cancel. And I'm going to get negative 1y equals 10. So y will equal negative 10 when I divide. Again, you can plug it back in to either the red equations or come back up here to black. I'm going to use black. The numbers are smaller and I think it's a little easier to work with. So I'm going to go ahead and take this negative 10 and I'm going to plug it in right there. So I'm going to get 3x plus 2 times negative 10 equals 1. So 3x, that becomes a negative 20. I'm going to add the 20 over and get 21 and then divide by 3 and get 7. So my coordinate point will be 7, negative 10. All right, and let's flip over to the next page. Okay, an example E here. So let's take a look at this guy. Again, we don't have anything that's going to match. However, if I look here, like if I just think about looking at my x's, okay, let's go ahead. Keep in mind that there is technically a 1 in front right here. So when I look at these x's, I'm going to multiply this guy, or really this whole guy, by negative 2 to get them to cancel. So I'm going to multiply here by negative 2. So I'm just going to write down my top equation, 2x plus 6y equals 18. Again, I didn't do anything to that. And on the bottom, I'm going to get negative 2x, because again, keep in mind, we're multiplying all 3 parts by it, minus 6y equals negative 18. So now, when I look at this problem, this one's a little funky, because the x's cancel, the 6's cancel, and the 18's cancel. Everything cancels here. So on this side, we have nothing left on this side. On the right-hand side, we have nothing left over there either. So just like in substitution, when we had like 0 equals 0, that would be IMS. Okay? If for some reason you were to work it out and get something like 0 equals 4, Well, that's not going to work, so that would be your no solution. Okay, that concludes notes for lesson 6.3.